Alright, in this video we're going to look at factoring. On this page I've started off with something called a difference of squares type problem. These are actually probably the easiest problems to factor. And basically, as long as your first term is a perfect square and your last term is a perfect square, these can be factored very simply just by taking the square root of both the first term and the last term. So as long as it's a subtraction in between as well. So the square root of x squared is just x, and the square root of 49 is 7. So what we're going to do is we're going to put x and 7 in both parentheses, and then one of them is plus and one of them is minus. Okay? That way, if we were to multiply this back out, x times x is x squared. X times negative 7 is negative 7x, but that cancels out 7 times x, which is positive 7x. And then 7 times negative 7 is negative 49, and we get back to where we started. So for this next one, they're both squared, subtraction in between. So we can square root the x squared, and we get x. Square root the 16, and we get 4. So x and 4 in both parentheses, one of them plus, one of them minus. Here's one, may look a little bit more difficult, but we can square root x to the fourth, and we can square root 81. Since there's a subtraction in between, let's square root them both. So x squared plus 9 and x squared minus 9. Now, this time we're not quite done yet. X squared plus 9, those are both perfect squares, but we're adding, so we can't do anything with that. But for the one on the right, x squared and 9 are both perfect squares, and we're subtracting. So we can actually factor that further. We can square root the x squared into x and square root the 9 into 3. So we get x plus 3 and x minus 3. And then we keep the x squared plus 9 that we had before. This is completely factored now. So this is the answer that we'd be looking for. Okay? So those are examples of factoring a difference of squares. Now let's take a look at just some general, fairly simple factoring problems. So anytime you're starting off with just an x squared here, we're going to start both of our parentheses with x. And then, since we've got a 3 here, that means the two numbers at the end of the parentheses have to multiply to give us 3. Well, the only way to do that is to make one of them 3 and one of them 1. Okay? Also, it's a positive 3, which means either these are both going to be plus or they're both going to be minus, because they'd have to multiply to give us a positive. Since this value in the middle is positive, they must both be positive. Okay? And let's double check that. X times x is x squared. X times 1 is 1x. 3 times x is 3x. 1x and 3x gives us 4x. And then 3 times 1 is 3. Okay. So if we move over here to the one on the right, again, we're starting off with an x squared, so it's just going to be an x in each parentheses. And we need two numbers that multiply to negative 18. So now this is where it gets a little bit tricky. We have 1 and 18, 2 and 9, 3 and 6. If we tried 4, that doesn't work. We try 5, that doesn't work either. And then we'd get back to 6, and that would be the same as 3 and 6. So it's got to be one of these combinations. What we need to look at here is this middle term. It's a negative 7. So we want to know which one of these pairs can we combine to get a negative 7. Well, 1 minus 18 would be negative 17, and 3 minus 6 would be negative 3. But 2 minus 9 would be negative 7. So this is the one we want to use. We want to use 2 and 9, and we said we would need to do 2 minus 9. So a positive 2 and a negative 9. So let's check that out. X times x is our x squared. X times negative 9 is negative 9x. 2 times x is positive 2x. So a negative 9 and a positive 2 does give us that negative 7x. And then positive 2 times negative 9 is negative 18. Okay? So those are fairly simple factoring problems. Let's look at one that's maybe a little bit more complicated. So here we have this 8 value in front of our x squared. So we're not just going to be starting with x squared x in each parentheses. So I'm going to show you a specific method for factoring, and that's using a generic rectangle. And what we're going to do is we're going to put this 6x squared in the top left and the negative 12 in the bottom right. And then we're going to come over here, we're going to make this x, and we're going to multiply those two values together. So 6x squared times negative 12. And that gives us negative 72x squared. Okay. Then what we're going to do is we're going to take this positive 1x and we're going to put it down here on the bottom. Okay, so that middle term goes on the bottom. We multiply the first and last terms, that goes on the top. Now what I'm looking for is I'm looking for two numbers that multiply to this top value and add to this bottom value. So 72 has a lot of multiples. And if you have to, just start writing them down. 1 and 72, 2 and 36. Okay, so just take 72 divided by 2, that's 36. 72 divided by 3, 72 divided by 4, and keep trying those. But something else that you might notice here is that we need them to combine, to add, to be a positive 1x, which means they can only be 1 apart. So we're actually looking for two numbers that multiply to 72 that are only 1 apart. That has to be 8 and 9. Okay? And since we want them to add to be a positive 1x, we need the bigger one to be positive. So the 9x is positive, the 8x is negative. And we're just going to put these in our box here, and it doesn't matter which one you put where. But now what we're going to do is, I'm going to start with this first column. And I look at that first column and I ask, what do those two values have in common? 6 and 8. They're both divisible by 2. And x squared and x, they both have an x. So I'm going to put a 2x up at the top here. Now I'm going to move over to the top left, and I'm asking, if I've got 6x squared here, I would need to take 2x times what to give me 6x squared? Well, 2 times 3 would give me the 6, and x times x would give me the x squared. So that's going to be a 3x. Now I'm going to go to the bottom left, and I do the same thing. 2 times negative 4 would give me the negative 8, and x times, well, I don't need anything because I already have, all I have down here is an x, and I took that out. And now I'm going to move over here to the top right, and I've got 3 times 3 would give me 9x, and the x I've already taken out. Okay, so basically what you're doing is you're thinking about these little rectangles as you're finding the area. So 2x times 3x, length times width, base times height, is the area of a rectangle. 2x times 3x is 6x squared. This one has a width of 3 and a height of 3x. 3 times 3x is 9x squared. Bottom left has a width of 2x and a height of negative 4. 2x times negative 4 is negative 8x. And then we can double check our answer by looking at this bottom right box here. It has a width of 3 and a height of negative 4. 3 times negative 4 is negative 12. So now we have our answer. We've got a 2x plus 3 on top. We don't have the plus written in between there, but it's a positive 3. And then on the side here we have a 3x minus 4. And that is factored form. All right, let's look at one more example. Sometimes you're given a problem where if you look closely enough, you'll see that they all have something in common. And actually, I'm just going to change this even a little bit more here. Okay. So now when I look at this, the first thing I'm looking at is the 6, the 32, and the 10. Those are all divisible by 2. So the first thing I'm going to do is I'm going to take out a 2. And then they all have an x as well. X cubed, x squared, x. So I'm also going to take out an x. Okay. So if I want to end up with a 6x cubed, 6 divided by 2, that's 3. And if I take an x out of x cubed, I'm still left with x squared. 32 divided by 2 is 16. And if I take an x out of x squared, I still have an x. And then 10 divided by 2 is 5. And if I take an x out of 10x, there are no more x's on that. So I've factored out the 2x, but now I still have this stuff inside here that I need to factor. So I'm going to go to my generic rectangle, and I'm going to, remember, put my x squared term in the top left, my 5, my constant, in the bottom right, and I'm going to multiply those together. So 3x squared times 5 is 15x squared. And then remember, you put the b term, the middle term, down below, 16x. So I'm looking for two numbers that multiply to 15 and add to 16. So I've got 1 and 15. 15 isn't divisible by 2. 3 and 5. 15 isn't divisible by 4. So those are the only two options. But I need them to add to a positive 16. 3 and 5 only adds to a positive 8. So it must be 1 and 15. So 1x and 15x. And I plug those into my rectangle. And then I look at this first column. 3 and 15 are both divisible by 3. And x squared and x, they both have an x. Now I move to the top left, and I ask 3 times what would be 3? Well, that's 1. I don't need to write that. X times what would be x squared? That's just x, so 1x. Come down to the bottom here. 3 times 5 would give me 15, and I already have the x. And then I come over here to the top right. X times 1 would be x. So now I have my answer. I want to keep that 2x that I started with. And then one parentheses, I'm going to have 3x plus 1. And the other is going to be x plus 5. And that is completely factored. So we've got a lot of different ways to factor, a lot of different types of problems that can be factored. Hopefully this helps with identifying kind of the different methods that you can use when you're trying to factor some of these problems.